2600 BC, the ancient Egyptians built these monuments to their gods and to their rulers called pyramids. And for thousands of years, people have wondered just exactly how did they build these pyramids. It seems to be a mind-boggling idea with no equipment in terms of the type of equipment we have today. So how did they do it? There are some that speculate the method was a simple sled device, where they would put each stone on a sled and hundreds of men with ropes would pull these up these ramps made of crushed granite. And on the bottom of these sleds were runners. And sometimes they would use water, sometimes they would use animal fat to help lubricate that. So one could say that maybe that was the first linear bearing in history. There are others that believe that it was a little bit more sophisticated, and in fact the stones were carried up these same ramps using carts, and those carts were simply a single axle with two granite stone wheels, and in the middle of the stone wheels were square wooden blocks which the axle set through. What makes this interesting is that there's archaeological evidence that shows inside those wooden blocks were copper strips or copper plain bearings. So was that truly the first self-lubricating plain bearing recorded in history? We don't know. And then there's others like me who subscribe to the idea that maybe the pyramids were built by the aliens. Who knows? I don't think we'll ever really know. Jump ahead a couple thousand years into 1500 AD. Leonardo da Vinci drew out what is the first concept for a ball bearing. And what makes it very interesting was that ball bearing was associated with his early drawings for a helicopter. And this is in 1500 BC or AD. Jump ahead to the 1600s. Galileo came up with the same concept for a ball bearing, but in his case it was a caged bearing, which by his design was more efficient and in fact could be made with self-lubricating type materials like woods. So for the next couple of hundred years there was more and more development of bearing type materials, but it wasn't until the Industrial Revolution when new technologies came that required all new material, and bearings were a big part of that. Machine tools, airplanes, cars, appliances, all of these things came into play during the Industrial Revolution in the early 1900s. 20th century, that's where everything happened for us. Hi, I'm Dave Bearing, Technical Director at TriStar, and welcome to a special Tech Talk. Our Tech Talk this time is really not about a particular material or a particular application, but instead we're very pleased to introduce our new white paper on plain bearing design. And we hope that you'll find this paper to be very comprehensive. It's about 32 pages, and we cover a lot of information in this presentation. So what I'd like to do is give you just a brief introduction of what you'll see in the white paper, and hope that you'll take advantage of it and learn more about the whole concept of plain bearings. You know, the 20th century was really the century of chemicals, and it's those chemicals that ultimately became polymers, which is what we use today to make our self-lubricating plain bearings. Starting really in the 30s, we had the nylons and PTFE, and even earlier than that, Leo Baekeland developed what became known as Bakelite, and today we know it better as phenolic or micarta type products. And so it was during the 30s, 40s, 50s, and 60s that we saw the greatest revolution in the development of polymers. And then when NASA began their race for space, that's when things really began to happen with the high performance materials. A lot of the materials that we use today in everyday use, like in automobile applications, are a result of the space race. And so today we have literally hundreds of materials to choose from. And our focus with this paper and our focus here at TriStar is how to apply those polymers into plain bearing, self-lubricating applications. So the first thing we talk about is just exactly what are the advantages of a plain bearing versus a metal bearing. And I hope that you'll take advantage of some previous videos that we did on why metal bearings fail, because that will lead right into the whole concept of plain bearings that we're talking about in this white paper. So what exactly are the advantages of a self-lubricating polymer bearing against a rolling element metal bearing? Well, first of all, no maintenance. No maintenance means less cost. No grease. Since these are all self-lubricating materials, we really don't need grease, and we really don't want grease. Grease becomes a contaminant source, and for that reason, we don't want you to really use grease in a plain bearing application. High performance applications. There's such a variety of materials now. We have applications where we can go down into cryogenic environments. We can go up to 1,000 degrees Fahrenheit. A variety of load situations, a variety of speed situations. There's just a number of different ways that you can take polymers now for self-lube plain bearing applications. These materials are lightweight, so much so that some of the materials offer a 7-to-1 weight to strength ratio, or strength to weight ratio. That's a big thing when you're trying to decrease weight in equipment to make it more efficient. Sanitary. A lot of the materials that we offer meet all of the regulatory requirements of FDA, USP Class 6, NSF 3A, Canadian Ag. There's lots of different materials that are available to meet all of those regulatory requirements for sanitary applications. And then corrosion and rust resistance. Because these are all polymers, they're obviously not going to be prone to corrosion. There's nothing to corrode. So as a replacement for a metal bearing, as long as your loads and speeds are within the capability of the polymer, corrosion and rust become a non-issue. And then finally, flexible design options. We have the ability to work in services like rotary, reciprocating, oscillating, cantilevered loads, misalignment, all kinds of things that can be accommodated with the right polymer material. From there, we jump into a review of a lot of the physical properties, mechanical and thermal and electrical properties, so that you have a better idea of what the key properties are that we look at when we're designing a polymer plain bearing. Things like tensile strength, elongation, flex modulus. We talk about impact strength. We talk about abrasion resistance. We even talk a little bit about the cost comparisons of different materials. Obviously, like anything else in life, the more you pay, the better the material. Again, as long as the material meets the criteria. But there is a very definite span of cost, and that comes into the consideration as we look at plain bearing design. We beyond the application or the review of actual properties, we also talk about the important things of plain bearing design, like PV. What is PV? How do you determine what the PV is of a particular application? We talk about K factors, which in the case of a polymer bearing is the ability for us to compare materials side by side in a singular application. We don't necessarily use K factors to calculate out the wear life of a material, but it is a good comparative piece of information that you can look at how materials differ from each other, and that becomes a guideline for you. We'll talk about thermal properties, dielectric values of the different materials, a lot of technology now in ESD applications, and that's all also applicable to bearings. And then we're going to talk in the paper as well about some of our Tier 1 products at TriStar. These would be materials like the Rulons. Rulons are a whole family of PTFE-based materials, obviously low friction, self-lubricating, a very broad temperature range, chemical resistance. This is where the Rulons really come into play in application. We also talk about our CJs, which is our filament wound product. We have a whole family now of different liners, things that can accommodate different speeds and loads, and in the case of the CJ, very high loads, and now some pretty high speeds as well. Following that, we've got our UltraComp materials. which is another type of composite. This is a laminate wound product. And again, very high loads. In this case, the speeds are lower, but in the case of the UltraComp, we have a product that's bearing material through the wall. So there really is no situation where you've got a liner to deal with. It's bearing through and through. Next, we have our Tri-Steel that we talk about. The Tri-Steel bearings are metal back bearings. And again, we have a family of different liner materials to accommodate different applications. We have a variety of different backing materials: stainless steel, bronze, steel. And all of these can be used in simple, cost-effective bearing applications, mostly lift and tilt, linkages, things like that. But we'll be talking about the Tri-Steels. High-performance materials. We talk a little bit about what that entails. And again, high-performance materials is a whole group of materials that are capable of operating at 400 degrees and above. And those are really the Cadillacs of the plastics world. So, again, we cover a variety of different materials. As you can see here by our material triangle, there are many, many different options that we have. And so we have the ability to dial the material into your particular application, and that's really what this paper is all about, is helping you to understand what that process is, and hopefully bring you to the understanding that TriStar really is the specialist in this type of product, and that we're here to help you make the right choice of materials, help you with the geometry, to be sure that right out of the box, that application with that polymer bearing is going to work for you. Some other things that we review in the paper is some of our old Shooting Star entries. These are actual applications where we've utilized different materials. We also have a application in there that talks about our surface modification. So the paper is we feel it's very well done. It's very concise, and it brings to the front all of the key factors of what plain bearing design is all about. So we hope that you'll enjoy the read, and hope that it'll prompt some questions. And we of course invite you to contact us through our Ask the Expert or directly to our engineering department. We're more than happy to help you with design. And then be sure to check out some of the other resources on our website, our blogs, our Shooting Stars, of course, our material database, which is expanding and improving constantly. So we want you to utilize all these. Of course, there's over 100 other videos as well, so all of this can tie together if you have specific questions on friction, on PV, on bearing design. There's topics all over the board that you can review. So anyway, that's what this Tech Talk is all about. I would like to acknowledge the assistance of our friends at Quadrant. We count on them a lot, and depend on them for good products and also for technical assistance when it comes to engineering and high performance materials. So thank you to the Quadrant folks. We hope this has been of value to you, and look forward to talking to you soon. And please share this white paper with others, or share the link, and spread the good word. Self-lubricating plain bearings are here to stay. Thank you.